Okay, so I hope that you're seeing my screen now. So this is the quick introduction to what is a jammer detector. So in fact, we need to understand first what is a jamming attack. So a jamming attack, it's mainly an attack on the physical level of any kind of wireless signal. So it's kind of a way to generate so much noise in the physical level of a wireless communication so that you cannot even uh, detect the wireless communication that was supposed to be received. So, for example, if you have a Wi-Fi connection, the problem that generates a jammer is that it generates so much noise that you're unable to determine what is a wireless signal coming from your Wi-Fi or a wireless signal coming from the jammer. And therefore, you cannot even understand and translate back to some information the physical wireless signal. Okay, so you see here that this is a jammer, and then what it generates a jammer, it's a kind of interference in this signal in order to that does not allow the receiver to reconvert this signal to something understandable. So as this is something that typically is perceived as, okay, I have problems receiving my wireless communications, but I don't know why. I just have problems and I cannot explain why these problems are happening. So this is why we generated this jammer detector, because the jammer detector is able to identify which anomalies on the physical layer are being caused by a jammer. And it makes quite strange things analyzing the wireless spectrum and so forth. But we provide a very simple interface, which you have a level of which is the signal to noise ratio. So if there's a lot of noise being generated by a jammer, then the signal to noise ratio is above zero, and you will see that there's a problem being caused by a jammer. Uh, whilst if there's no jammer, you will see that everything is fine, no signal to noise ratio above zero. So, and what's typically used a jammer? So typically, jammers are used, for example, if you, to interfere with the communications of wireless video surveillance cameras. So, for example, that might happen in some video cameras are fully wired because they are close to the main building, or they have connection to your cabled network, but some of them might be on the edges. Then there are no wired cables there for your cameras, and you decide to just put a wireless camera out there. The problem of wireless cameras for CCTV is that if you just turn on a jammer right next to the camera, what you will see is that the image is frozen because they are sending continuously the latest image to the control room. But if the camera believes that they are sending the image, but at the control room there are no images being received because there's too much noise, and you cannot reconvert back to the images sent by the camera. And what you see is that the camera is frozen. You see like everything's fine because you don't see anything moving, but the problem is that there is there is people going there because they just use this jammer to freeze the signal, and then they can just do whatever they want to do. And that's a problem for CCTV control rooms, for example. And a way that the jammer detector could kind of avoid this special situation is like having a small screen also at the control room, and having the information of whether there is a jamming attack in some areas or not. And for example, the system is able to support several sensors deployed around the infrastructure, and you can see quite clearly with green and red colors if there's an attack in some area or not. So this is kind of the very simple interface that we generated, but you can also integrate with your own existing alarm monitoring systems that you might have. Okay, so that's the explanation. I don't know if you have any questions regarding the explanation. Okay, sure. Okay, now I was just testing to make sure that we're ready. So okay, so let me present this here again. So here, this is the general interface for the Jammer Detector. So you have the general status of the jammer, and what we did in the 2.4 gigahertz is having several types of jammer attacks also being possible to detect. So, for example, what we also prepared for the purpose of doing this kind of demos is that we recorded the signal of specific jammers. And that's why we have this very simple interface to define a jammer signal. And now, as you will see, that now we're detecting the attack of this pulse of this continuous wave jammer, and you can see here as the signal, so the jammer to noise ratio, or the signal to noise ratio, it's quite above 0, and this means that we're detecting an attack. And that's the very simple way to detect that there's a jammer attack. We can now stop the jammer, and now we will see that the jammer to noise ratio starts back and goes back to 0, and this means that the jammer was just stopped. And that's the very, very simple interface. As I said, this can be integrated, the output of this system, which is an alert of that a jammer is being detected. This can be sent and integrated to any kind of CM or any kind of alert management system that you might have in your infrastructure, or you can use this simple interface, which of course it could be further enhanced and can be provided with modifications.